welcome back. We're going to keep thinking about the data that we worked with in the last video, where we were thinking about how to represent a lot of information by the mean and error bars showing the standard deviation. And so we're just going to pick up with the same data and think of a different way to solve this unicorn main. So to remind us where we came from, we basically had data that looked like this, where we had housing prices every state by decades from 1940 to 2000. And we'd like to represent this as like some sort of scatter plot or something like that. All right, what we did last time was we imported state data. And so that gave us row by row information because we didn't unpack during this gen from text reading. So that gave us row by row. So state by state, what's going on. We had state names that we brought in as well by just reading the first column and unpacking so that we got it in the column structure. And we decided that we could try to show all this data on the same plot, but it was a bad idea because we got this unicorn main that was hard to deal with. And our solution last time was to represent everything here by this average plot. What I want to show us today is how to solve this using what's known as small multiples. And the idea behind this is that we would take the data for every single state and put it in its own plot, and then arrange all the plots for all the states together into a grid so that it's easy to compare them at a glance without having them all be overlaid like this. So what we need then is a grid of plots to put data into. So let's call this grid plot. I guess we could call it small multiples, but this is less typing. And we're going to make subplots. And now we are going to see why we've been using make subplots every single time this semester, even when we haven't needed grids, because now we're going to get a grid and we don't have to learn anything new. So there's 50 states. How about we have them go 10 states across and 5 states down? So we might say then that there's going to be 10 columns. So columns equals 10, and then 5 states down, that's how many rows we have? 5. If I do this, I will get now a figure object that's expecting there to be 50 plots, or at least there already are 50 plots, and we just have to add data to them. All right. So let's go ahead and do that. What I would like to do now is go through and get every single one of the states row by row. We know how to do that already for D and state data. We added it to the plot. We're actually going to do the same thing here. And so we're going to just take this and we're going to say for D and state data, add to this grid plot. I'm going to run this and we'll see that it doesn't do what we want it to do yet, but then we'll go ahead and fix that. So then I'll say grid plot.show. Right. Okay. How about we'll go SD. We can't define the same variable twice in Marimo. There's ways around this, but let's not worry about it yet. All right. It doesn't look like we've solved this problem. I told you it won't have. It kind of looks like this plot up here, except worse, because we have this legend and all this data, but it's just like super compressed. And the reason it's super compressed is there's a grid of plots. There's a plot here, 2, 3, 4, 5, 6, 7, 8, 9, 10 across, then 11, 12, and so on until I have 50. And because I didn't tell this where to put anything, all right, it's just put it all in the upper left. What would be plot number 1? Okay, so what we want to do is not only add it to the plot, but add it to a particular row and column. So I would say add it to some row equals something and column equals something. And I would, like, let's say I put these all in row 2, column 3. I'll have the same problem. It'll just be not in the upper left, but in row 2. So down 1 row and over to the 3rd column. All right. One thing that's happening here that I need to be explicit about is when you use this grid plot, counting starts at 1, which is a little unfortunate because in Plotly or in Python, most things we start counting at 0, But in Plotly, we're going to start counting where the grids are with 1. That's just unfortunately how it works. So there we have it. Okay, that's also not what we want because it had to change every one of these 50 times in a row, right? So one option would be to like get the individual states and assign it to each thing and have this giant list of 50 things. We're not going to do that. Let's introduce a new tool for how to solve this problem. So let's go back to the idea of this for loop. So again, let's say I have test equals 1, I think we had 2 and then 3.0. We don't really have to do the same thing, but let's just do it anyway. So then we could say for t in test print t. All right. Yeah, I don't need the colon at the end of that line. All right, so we had this. It would be nice to know what element we had. And one way to do this is that we can use the function enumerate. Now what enumerate is going to do is it's going to give us not only the item, but what number item it is or what index position it was, right? So it's going to print t, that's 1, here's 2, here's 3. But along with that, we have 0, 1, and 2. Okay, so this is the 0th position has the item 1. The first position has item 2. The second position has this 3.0. That's what it's telling us. And so it's giving us a way to count. Now it's returning this technically what is called as a tuple. It's like a list, but just a little different, and it designates that with these parentheses. We can unpack this into 2 values. So now if I do this, it's going to assign the counting 0, 1, 2 to I, and then 1, 2, and 3 to this t. All right, so now if I do this, you'll see print is just giving us these values. If I had something like maybe I make an F string, I could say the item at index I is t. You'll see the item at index 0 is 1, the item at index 1 is 2, the item at index 2 is 3.0. All right, so it's counting the indices. At the same time, it's giving us the values. That's great because we can use this now to assign things to the different columns. And the way we're going to do this is we're basically going to say that the columns, we need to enumerate this data. So we'll say enumerate the state data. And then again, we want to not only have SD, but let's call this I underscore I. We'll use underscore I. Column the row. I'll just type out what this is and then we'll explain it. So underscore I divided by 10. And then the column, let's set this as underscore I, then %, 10 plus 1. Oh, I should put a plus 1 at the end of this too. So let's see what happens when I do this, and then we'll explain how it worked. Okay, look at this. Now we have all of our grids having different data. We're on the right track for showing all the different performances for the housing prices over time. It's kind of a mess. We're going to clean it up. Don't worry. Let's think about how we got this to work. So this row int means let's make an integer. So if I have something that has decimal places, I'm going to just chop off the decimal place and take just the whole number. I'm going to take I, which is how I'm counting. I'm going to divide it by 10 because there are 10 columns. And then I'm going to add 1 because counting starts at 1 for Plotly. So if I start with I is 0, I'm going to divide by 10. That's going to give me 0. And then I'm going to add 1, and that's 1. So that means I'm in row 1. Let's say that I get to my 5th item. So 1, 2, 3, 4, 5th item. I still should be in the first row. So here it would be, I have my 5th item, so I is going to be 4. I'm going to divide by 10. That's going to equal 0.4. So 0.4. I'm going to convert it to an integer. So I'm going to chop off everything that was the decimal place, and I'm going to just get back 4, or 0, sorry. And then I'm going to add 1. So it keeps me here. It keeps me there until I is equal to 10. So this would be the 0th index, 1, 2, 3, 4, 5, 6, 7, 8, 9. When I get to the 10th thing, it's now going to be 10 divided by 10, that's 1. And plus 1, that's 2. So that brings me down to the 2nd row. And we'll just keep doing that over and over and over again. Now, let's think about what's happening here for the columns. In the columns, we're using what's known as the modulo operator. And what we do is you can think of this as counting how many times we go past an even divisor of whatever number this is. Like, this is a little complicated, but that's what's going on. So let's just illustrate it with a quick example down here. So let's say that I have a number 1 and then modulo 3. That gives me 1. What if it was 2? That gives me 2. What if it was 3? That gives me 0. What if it was 4? That's 1 again. 5, 6, 0. And so essentially what's going on is that we look at how many times the number to the right can go into the number to the left, and what's left over. And then we only think about what's left over. So 3 goes into 6 twice with nothing left over. Nothing left over is 0. But if I had 7, 3 goes into 7 twice with 1 left over. Also, if I had a 4, 3 goes into 4 with 1 left over. If I had 10, 3 goes into 10 3 times with 1 left over. So I get the same answer over and over and over again. It's basically after I've divided whatever number this is into this number as many times as I can, what's left. So then when I return back up to here, we can see what's going to happen. When I have 0, when I start with index of 0, I divide by 10. It goes in 0 times with 0 left over, and I add 1, so that's the first column. When it's 1, 10 goes into 1 0 times, but 1 left over, and then I add 1, and that gives me 2. All right, I'm going to keep doing that. What happens when I get to like 12? When I equals 12, 10 goes into 12 once with 2 left over, plus 1, so that's the third column. That would put me 1, 2, 3 here. Okay, so that's what's going on. And we can, if you want to verify that math right, what I just said was if I had 12 and I did modulo 10, I should expect 2 left over. There it is. And then I would have added 1. That's that third column. And so this is how we're going across rows and down columns and spreading this out over those 50 different possibilities. Okay, so that's how we got the data here. This isn't pretty yet. That's okay. Let's go ahead and make this more useful. Something that's a problem is that there's just like labels all over the place. It's very cluttered and hard to read. What we could do if we wanted is we could make there be like more margins between all the plots so that there's room for all this labeling, or we can get rid of some of the labeling. When you make a subplot, one of the options that we have is to say shared axes. So we'll say shared x-axes, and let's see what that gives us. Now you see I lost all the labeling on all the x-axes except the bottom ones. Then let's go shared y-axes equals true. And now I've lost all the labeling except on the left. And what ends up happening is that all of these share the exact same scaling across a row, though that scaling may change as we go row to row to row, which I don't really like. It would be nice if all that scaling was the same. And so On the x-axis, I don't really need to do that because the years that we have are all the same, but on the y-axis, I should. So let's just go ahead and change that. So this is grid, plot, and then we'll say update, y-axis. And I don't want something like this where this one goes to 150, that one goes to 150, that one goes to 200,000, that one goes to 300,000, and so on. So what I would like to do is have a range that spans, let's say from 0, maybe we don't want 0, I think 0 is a fine place to start, to the maximum of all the values that we have. And so we could go, it doesn't really matter as long as we have all the information we want. So let's just go the maximum that's in the state data. Now all of these share exactly the same y-axis. They go from 0 to the highest value that's present in any of the data sets. It's a basic idea about what's going on here. Okay, so now we have essentially what's small. This is small multiples. Okay, we can continue to improve it, but this is the basic idea that we just repeat over and over and over again. Now we have no idea what is what right now. So there's a couple ways we could do this. One is we could add something to the legend, all right, where we say what each state is, but we have the same problem where it's going to be hard to assign colors because I have 1, 2, 3, 4, 5 different options for each color to assign here. And so there's no way to really unambiguously do this. It would be nice if what we could do is add what amounts to a title to each one of these subplots, or titles of these subplots. So let's do that. There's an option when we use make subplots that lets us have subplot titles. And what we need to supply is an array of strings that are the names that we want for each one of these going across the rows and then down across the row, or down across the row. And we already have this information. So we had already imported before what the state names were by reading just the first column in our data and unpacking it, so that when I have this array, it's just an array of these state names. So that means that this variable here, state names, can be passed to this subplot title. And when I do that, you'll see I have put the name of every state above the subplot. That's great. I don't need now any of these. And so when I add stuff as scatter, I can say show legend equals false, and that will give me a cleaner plot. I still have kind of a problem where some of these state names are sort of impinging on other state names. And so one way to handle this would be to change the size of this plot if I wanted to handle that, or to reduce the size of the titles. And so either one of those we can do in the update layout. So grid plot.update layout. And then if I wanted to try to control the font, I could say font equals dictionary, size equals, let's say 10. And now I've got slightly smaller names. Kind of works. We're starting to get these axis values that are a little too small. So maybe rather than doing that, let's just go ahead and change the size of the plot. So width equals, I don't really know how big this needs to be. Let's try 800. Height equals 500. And let's see what that looks like. All right, could be bigger. So one thing I like to do when I am playing around with this is I'll just multiply by sort of a number, and then I can control that. There we go. These are well spread out. I probably don't need this to be to, what if it was like 1.5? Would that look fine? We're not going to spend forever on this, but this is one way I hunt around to see what size I might want to have. But it's kind of working. That's just a little too small, so, or a little too close. So we'll just find the first size for which that works okay. Probably could still be bigger. And then we'll be done with changing the size. Something else that we could do, we kind of on the bottom here have problems now where on the x-axis, do I really need every one of these decades? Probably not. I definitely don't want text that's slanted. So let's go ahead and just grid plot.update x-axis range equals, well, we know what the range is. It's 1940 to 2000. And we could also say the number of ticks that I want is 2. Let's see what that gives us. Oh, in ticks, not in tick. And now, yeah, I have something where I just start at 1950 in this case to 2000. Maybe I don't like the way it chose those tick marks. If I really wanted to say where they are, I could say tick vals equals and then a list. So I could say, oh, I really want these at 1940 to 2000. And then of course they overlap. And so we'd have to think about, can we make this bigger, you know, spread out again more, or maybe, yeah, it made sense to maybe have something at 1950. And then this would have been for symmetry, 1990. All right. We could give this an overall chart title that would indicate that they really do run from 1950 to 1960. So how about a title here is between 1940 and 2000, home prices increased in every state. All right. Now we have a label that sort of helps us make sense of what's going on even with these x-axes. We could decide whether we want to have grid lines or not grid lines. We could change, of course, things like the template, right? So let me just go ahead and add that in. Template equals, we've always been using simple white. Maybe I don't need all of these to be different colors. So another thing I can do is I can go back to the scatter, and when I'm adding it in, I could just say, well, I just want the line. Actually, let's just make them lines and see if that, maybe we don't need the markers. So we'll say the mode equals lines. And then just put this down here. And then let's say line equals a dictionary, color equals, I don't know, I kind of like dark cyan. We'll use that for right now and see what we think. And yeah, it's fine. Let's see what this looks like. Okay, now we have a bunch of simple lines. Not too bad. If we wanted to, we could go back and we could call out a particular plot. So for instance, if I look at Hawaii, this is the one that had the biggest overall change. All right, you can verify that for yourself if you want to look at the plot you made. But this is Hawaii. So Hawaii is, if this is the 0th trace, the second trace, you can see it's labeled that when I hover, trace 0, trace 1, trace 2. This would be over to 10, or I guess 9 by the time I run out. So this would be the 10th trace, and there it is when I hover over it. I could go and I could change just the color of that trace. So not in this loop where I keep assigning things over and over and over again, but outside this loop, let's go ahead and say grid plot dot update traces, and then let's pick a selector equals 10. So we're going to work on the 10th trace. Actually, no, that's not the way this is going to work. We go to update traces. What we want to do is actually select the row and column. So Hawaii is in the second row and the first column. We'll say row equals 2, column equals 1, line equals a dictionary, color, let's make it, why not red? Let's even make it bold. So how about width equals 10? And now I have this, that's like too bold. That's kind of comically bold. Okay, how about 5? There we go. Now I have something that stands out quite a bit versus everything else. And then we could have a title that said between 9 and 40, Hawaii had the Hawaii home prices. Now we're emphasizing Hawaii. Okay, so this is kind of one way to show all of this data. There are other things that one could do. We don't have to talk about it here. If you're interested, you can come chat with me about how this would be, or you could think about how you might do it. For instance, you could show on each one of these plots all the data. All the data would be in gray except maybe like this cyan or the one that corresponds to the state we're looking at. Maybe we could try to figure out how to color code the word Hawaii to red or this Hawaii to red. These are all things that are possible, but we're not going to cover in this video, because in this video we were just showing how to use the grid system so that we could assign a trace for one state to each one of these plots, and we've done that. And in another video, we will think about this plot again and how to fit data, and that will basically be the end in this course of thinking about the sort of the individual things we can do in all our different plots, and then we'll think about how to make lots of different kinds of plots. All right, so now we have a new tool for showing lots of data, right? We can either, when we have a situation like this, summarize them by taking things like means or some sort of other summary statistic, or we can make small multiple plots like this, where we spread out the data and they're easy to compare from one plot to another. And with that, I'll see you next time.